And she goes, I only need 8.
All right. Coming in hot, no daily quiz, but show me that you remember what the crap we were doing yesterday. Go.
No, I have Whitenberg first block. I was building Howard's shed at his house.
It's fun going out there.
You guys,
We only know 3.
yeah, on Friday I have to go at 7 a.m.
That might not be as fun. What? I didn't buy it. Sure, man.
I have to do all my laundry. I have to do laundry. Well, because I got back from the gym at 30.
Oh, so now so at 8. That means you have to stay on until. Dude, and then
It smells good.
it was like 10:45 or so. And the sauce is what? Very good day.
That was pretty cool than yesterday.
Same temperature every day. It's almost like there's a climate control unit right above my room.
Maybe. That could be it.
Forgot you said that
And then same food. It's really good. And then, are you excited? No. Not at all. Like, I honestly just Are you going? I've done that.
Okay.
Yeah, exactly. So now I have to. And I'm missing so much. And then, like, I'm missing the quizzing here. My history test. Now goes into my test. No, I mean, and Friday. Oh, no. It's all
Yeah, put that
I was wondering if you had the review for Friday. No.
That's adorable. You think that I have stuff planned 2 days ahead.
Well, I wasn't sure. I thought it was worth a shot.
She had open. It's adorable.
Hey, we don't do any better stuff.
We're doing a test Friday. Yeah.
After last hour, I don't know.
Did it go back?
I might have to push it back to Monday.
I'm okay with that. Wait.
On Monday?
I'm okay with that.
I'm not sure.
What happened last time?
First hour decided not to do 7-1 and has basically been chasing the bus ever since last Friday. But if you all do great today, then I'm just going to say, find out.
And then plus.
Oh, we had to both sides.
12, 16, 22, 24.
Oh, and it goes like this.
So we take
Minus one.
Can we mental math in the morning? 25.
What's 225 divided by 9?
Why 9? 1, negative 25. 5 squared, 25, 25, 9. 25, 10. 250, 225. 225, 25, 9, and 25. Right?
I had 2 equal signs. Yeah.
That's what I got.
Oh, boy.
I'm doing mental math before lunch. Somebody better come out and check me. This is before lunch.
Okay, yes. The way you said it, I thought you meant right before lunch. So
Oh.
no.
Yeah, so since the Y's were
One on this one. Yeah, misunderstood.
Yeah, because 3, 4, 5 triangle.
Oh my goodness.
They kind of like those.
I don't have any time to stop to like save. Do
Okay. Stage 1. If I'm going to complete the square, and I know I'm going to do it twice because I see an x squared and a y squared, then I group my x stuff, I group my y stuff, I throw the constant to the other side. Are you okay if I factor along the way? Because I know I'm going to have to do it, right? Can't have that a value in there. Plus 9 y squared minus 10y is negative 25. Complete the square, but complete the square by making sure you actually add what you're really adding. Half of negative 2 is negative 1. Negative 1 squared is uno. But did I really add 1? 25 by 1. Half of negative 10 is negative 5. Negative 5 squared is 25. But 9 by 25. So we got 25, the quantity x minus 1 squared, plus 9, the quantity y minus 5 squared, it's always half of b, is 225. When I divide everything by 225, turns out that they were just factor pairs of each other. So once I'm there, are we okay graphing the thing? Can we find all the features? Because if you don't know how to find the features from the equation, you are not going to be able to do literally the next page of here's the features, find the equation, instead of here's the equation, find the features. Okay, so maybe I'll put that up here and we review those features real quick. Is this particular potato going to be stretched vertically or horizontally? How do I know? The a squared value is the larger one. The larger denominator is paired with y. So stretch along y-axis, I make potato like this. Then my center is always at HK, 1, 5. If a squared is 25, then a is 5. If b squared is 9, then b is 3. Which means I'm going to a in those directions, putting a vertex at 110, putting a vertex at 1, 0. I'm going to b in those directions, putting a 4, 5 co-vertex, and putting a co-vertex at, what's that, negative 3? Negative 2, 5. My foci. I got to find off to the side. C is the square root of a squared minus b squared. No, those are already squared. So C is the square root of 16, which is just 4. So this one worked out nicely. Doesn't always happen that way. Usually it's written as a compound number with a radical in there. But if I'm going to 4 in both directions for my foci, well, here's a focus at 1 plus 4. No, 5 plus 4. Poke, poke. A focus at 1, 9, and a focus at 1, 1. The reason I want to have that up here and start talking about some features is because we're about to use those features to write the equation. Remember that I A in this direction and I A in that direction to find my vertices. That line that connects my vertices is called what? Major axis. So if I A in both directions, maybe I should know that the major axis is 2A. If I B in this direction and B in that direction to find my co-vertices, I should probably say that my minor axis is what? And although it doesn't have its own special name, if I C to my foci or my focus and I C to the focus, then I can say that foci to foci is 2C. I suppose I just used double plural. Walruses to walruses. Focus to focus. Well, focus to focus is 2C. I used plural on both. Oops. It really is. All right, so I know those things. Also, notice that if I A in those directions and B in those directions and C in those directions, what is always in the middle of my vertices, middle of my co-vertices, middle of my foci. Okay. So
Seems like it could be okay.
see, I've got the image of that mansplaining meme where the guy's just like shouting in the girl's ear at the party, except it's Logan. That's why it's called the center. So, if the if the major axis is from -6,2 to -6, -8, sometimes we might need to sketch these out to tell what's going on. You don't have to, but sometimes it helps to say there's a point at -6, 2, and there's another point at -6, -8, and that is my major axis. That's going to tell me like 3 things right there without even looking at the rest of it. A. Literally, it tells me A. A is half of that distance. So from -6,2 to -6, -8 is how far? 10. So that means A is 5. What else does it tell me? In between there, I can find my center. My center is the midpoint. If you need to remember old midpoint formula, x1 plus x2 over 2. y1 plus y2 over 2. It's literally just middle of each, median of each. Or you can take that distance is 10 divided by 2 is 5, and I can go 5 north of this one or 5 south of that one, and I get a center of -6, -3. So I've got A, I've got my center. What else? Not yet. Because my major axis goes between vertices, vertex to vertex was north to south, I know that my a squared value is going to go with my y's because it was stretched vertically along the y-axis. So just from this, I've already got x minus thing squared plus y minus thing squared all over is 1. Yeah, we're going to get there. So midpoint of that gets me my center, -6, -3. So +6, +3. Now you can sketch it out a little bit like this, but it's not necessary if you just look at from here to here. And I say that's 2a is 10, so a is 5. Also, I know they're the y's changing. So I know that a squared goes with my y term. So all of that just from here's 2 vertices. The same thing goes for minor axis, same thing goes for co-vertices, same thing goes for foci. If I'm given any 2 points, I'm going to be able to find A, B, or C. I'm going to be able to know which x or y gets my a squared value. And I'm also going to know my center as the midpoint between any 2 points. And then along comes the minor axis, and I know that the minor axis is 2b. 2b was 6 units, b is 3, b squared is 9. Another thing to note about that, Notice that in this one, it was my y's changing. The x's did not, so that means my major axis was along the line x equals -6. My minor axis, the y's did not change, was along the line y equals -3. Look at what happens when I cross the lines. X is -6, y is -3. Okay? So there's a lot of ways to think about it to get these values. Use which one makes sense for you. So again, over here, I'll start that same process over. X minus thing squared, y minus thing squared, all over is 1. And vertices. I notice that the x's are changing, and the distance between them is 10. So right out the gate, my x's are changing. That means that this is stretched along the x-axis. So I know my a squared value is going to go with the x's. I just found out that a was 5, so 25 it is. I can find my midpoint. My midpoint, -4 plus 6 over 2, 4 plus 4 over 2, gets me my center. So, 1, 2. 4 plus 4 is 8. 8 divided by 2 is 4. Halfway between 4 and 4 is 4. I've got A, and the distance between the foci, we talked about this, distance between foci is 2c. Now don't make the mistake of trying to put that on my denominator. C doesn't show up anywhere in my equation. But off to the side, I can now say that if c is the square root of a squared minus b squared, then I can say 3 is the square root of 25 minus b squared. Square both sides, subtract 25, divide by negative. B squared is who? Okay, I just heard 4, 2, and 8, none of which are the answer. I'm adding interest.
Yeah, where's that sleep though?
Y'all, 9 is 25 minus b squared. Subtract 25, divide by negative. 16 is b squared. I asked what b squared is, not what b is. Because what goes under that denominator? B squared. I don't actually care about finding b. I want b squared. 16. Okay, so it's all about, do you know what the features of the graph do? Do you know which direction they go? Do you know that this is half of that? Do you know that square root of this makes that? If you understand how an ellipse works, I should be able to give you 2 features of it, and you're good to go. Let's see what you got. Because they have different features. So I want to practice both. Yeah, if I'm given components of major and minor axis, it's no big deal. But if you have the foci, you got to do a little bit of side work.
Wouldn't you add 2 because add 2 to this and subtract it from this? These 2 points. Day 15.
5x is tree.
They squared 245.
So two C's. Well, I got 15, but then you have to square. So if you use plus.
I mean, kind of. This is speed. I almost Oh, well, yeah. Either A or B would be 15.
Okay. Remember, the major axis goes through vertices and foci. That's why. Okay. So distance between vertices or foci or co-vertices is going to be 2a, 2c, 2b, respectively. Whatever is changing in those two coordinates tells you which way it's stretched, so that'll determine major minor axis. Additionally, if I find the midpoint of each, the middle of these is 6, 3 as a center. The middle of these is -2, what's that, 4, 2, 2. Okay? So just from the first set of coordinates that they gave you each time, you got all that information. So that tells me center, 6, 3. I've got my C value, not my A value, so I can't do anything with that yet. I've got my center at -2, 2. I know that my A value is 6, and it will go with the Y's, so 36. Then I move on to my second set of information. Major axis is 2A. That's a 30. So A is 15. I just said my A squared will go with X, so 225 goes under the X minus 6 quantity squared. Length of minor axis is 10, so 2B is 10, B is 5, B squared is 25. So this guy's already done. It's done because I was given major and minor axis information. But that turd, they gave me A and C. So I got to go on a little bit of a side quest here to say C is the square root of A squared minus B squared. I know what C is. I know what A is, or more appropriately, A squared. Square both sides, subtract 225, divide by negative. B squared is, what's that, 169.56? You ruined the punchline. Okay. Are we getting there? Like, are we starting to kind of see the matrix where you see all this information pop up from it? Like, oh, that means this. But wait a second, that means this. Oh, hey, that also means this. If you do, that means you understand the features of an ellipse. If you're having to go back and look things up, all right, we got to look things up. That's why everything's open notes. Now, if, on the other hand, you really are having trouble with that, and you need to go back to a more formulaic plug and chug concept, well, go back to the formulaic version of it. Remember, they just straight up tell you that my major and minor axis are going to be on the H and K, that my minor major for the other one, that C is always this. They tell me that my vertices are going to be plus or minus A to the H if it is stretched horizontally. They just tell me all that stuff. I can plug and chug numbers. So, last hour, they were also having a little bit of trouble with the things that involved the foci. So, dang, round 2. Do it again.
So A is 6, 2 C's would be 2.
Yeah, the center point. Yeah.
Oh, yeah, I wasn't.
C is 3, 3, 9, 25, 16.
This is the for C. I'm talking 6 times. This one. Okay, only on the major axis?
Yep,
Okay, well then that makes this a lot easier.
because that's my definition of an ellipse. All points such that the sum of distance from point to foci is equidistant.
Where is negative 2? Or I guess it's the major axis. I got that.
Yeah.
Now this is C. 16.
Oh, I am. Yeah. Well, anyway. I spun a lot.
Well,
Well, I'm going to have one. Might be the center.
just knowing that my foci lie along a major axis. If my foci lie along a major axis, then I'm able to draw my potato. That's really off center. Better. If I know the foci, then I can find the center. The center is right smack in between them. Do your midpoint formula. It's at -2. 7 plus 1 is 8. 8 divided by 2 is 4. So now I got my -2, 4 for my center. Good old midpoint. Yep. They tell me the major axis from here to here is 10. So A is 5. Because it's stretched vertically, I know that my A squared goes with my Y's. And then, if I know that A is 5, I know 2c is 6, so c is 3. I can put those two facts together and say 3 is the square root of 25 minus b squared. Square, subtract, divide by negative, b squared is 16. Okay. Yo.
Is this a spot where you can go 3, 4, 5 triangle and just write 4?
Not all the time. Because just like we ran into this in chapter 4, what happens when I say the arctangent of a thing is square root of 3 over 2? What's my angle? What's the other side? There's a lot of us who would see square root of 3 and 2, and we're so used to seeing 30, 60, 90 triangles with that ratio in them, we would assume a 30 or 60 angle. But because it's tangent, that's square root of 3 over 2. A squared plus b squared, this is square root of 7. It wasn't a 30, 60, 90 triangle. So don't assume just because you see a 3 or a 5 in there, it's always going to be a 4 with it. Right? Now, a lot of the time, yes. But don't make the assumption. Okay. Y'all ever hear the expression that a poor person is crazy, a rich person is eccentric? It's the idea that if you got money, you can get away with doing really stupid stuff. Okay? For example, I could fund the entire pandemic relief effort in the country by myself. Or I could buy a failing social media platform and blast myself into space. Make an absolute fool of myself online. One is a rational person, one is eccentric. You get choices, right? Eccentric means weird, off, different. But because it's a bigger vocabulary word, people apply it to folks who you don't want to call weird. But people be weird. Well, eccentricity of an ellipse is how weird it is. Think of it as a crazyometer. An eccentricity of 0 is a perfect circle because my focus is at the center. So the distance to anything around it is always the same. It is perfect. It is not weird at all. But the more eccentric something gets, the more that focus moves away from the center, the more it stretches that circle out. My crazyometer is at 32%. It's got a little bit of an oval to it. My crazyometer has hit 71% because the ratio between this distance and this distance is 0.71. Isn't C about 71% of the way to the vertex? And then what happens? It's getting in closer and closer and closer. What's going to happen when the crazyometer, when the eccentricity hits 1? It's just a line. You go from perfect circle to stretch, 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 and now it's just a line. Okay? So eccentricity, I hate that they use E. Oh, that bothers me. What is E? Natural base. It is the natural limit to a continuously self-referential growing function. We know it as about 2.72-ish, the same way that you know pi is about 3.14. So I'm going to say instead big E, because them, is a comparison of C over A. That's all it is. A comparison of distance to focus, distance to vertex. Well, if the focus is at my center, then C is 0. C is 0 means perfect circle. I have an eccentricity of 0. If it is perfect, it is not very weird. Okay? What you might want to put next to this, because of the information they're going to give us, is since I find C a particular way, I can also write it like this. Right? Blue is the definition, purple is how we're usually going to find it. So it's a comparison of how stretched out it is. Think back to one variable stats. A standard deviation is a measure of spread. It's how spread out my data is. Eccentricity is the standard deviation of conic sections. How spread out is it? How stretched is it? So before even finding the eccentricity itself, get back here. I want you to just think about this. Look at what your A and B values are going to be. Is this going to be close to circular or stretched out? Because I've got a value of 10 and a B value of 3, that means a major axis 20 units long and a minor axis that's only 6. Okay? Less of a ball and more of a needle. Okay? So finding the eccentricity is that simple. Eccentricity is C over A is the square root of A squared minus B squared, 100 minus 91, over A is square root of 100, or 10. Sorry, I'm jumping the gun. And 100 minus 9 is? Now, squared 91 over 10 may be the perfect answer, but it isn't a percentage on my crazyometer. So this may be the eccentricity. Go and give me the decimal approximation with it, because the number from 0 through 1 is my actual eccentricity. 0.9 what? 3 places, thank you. Okay, so very eccentric, very stretched out, very weird. Okay, think about this like Skittles. You open a bag of Skittles. Isn't that one Skittle a little weird? Isn't it a little eccentric? Looks more like Mike and Ike's. Okay? So, because it's a little different, it's a little eccentric because it's more stretched out than what we would consider normal. So, go find the eccentricity of both. Be careful that you know how to rationalize a radical because you passed Algebra 1 and have been working with simplified radicals nonstop for the last 3 years. Remember, not just the decimal equivalent, have the simplified radical version as well. There's the accurate answer, and then there's the answer most people will understand.
So do you want us to? No, wait,
I want you to simplify that first. And then, once you're done simplifying, then give me decimal to 3 places. You simplify that first. Always simplify. What's that? 6 and change over about 0.3-ish. Okay. Okay, the occasional scrunched eyebrows that I see just working with radicals is why Sullivan gets a little bit grumbly, because this is Algebra 1. I do this first semester with my inclusion Algebra 1, which is really more like Algebra 0.7. And you should have been working in simplified radicals all throughout Algebra 1 and geometry and Algebra 2. Okay? I get grumbly when kids come up to Algebra 2 and PreCalc and don't know how to do this stuff, because you should have done it 3 classes ago. And you should have been using it consistently in the meantime. I don't like it when teachers let you do whatever because it's just maybe difficult or irritating to have to keep reminding you to do it the right way. Now, you can, 3b is just rationalized by multiplying by square root of 19. On this one, there's more than one way to get to Deadwood. You can go there by route of Rapid City if you want. You can take the long road. Other way around. Square root of 48, yeah, that's 4 root of 3. What am I talking about? 3 times square root of 3 times square root of 3 times square root of 3. And 5. I hate doing the long way. Getting 12. Getting 12. Getting root of 10 over 4. There we go. Or I could go the short way. Like that. Recognize the compatible factor between them. Simplify that part. Square root of 16 happens to be a 4. One step instead of 5. That's a thing that you see if either A, you're really good with your numeracy, or B, you've been working with them for years. Okay? And then the decimal equivalent of that, what's that, like 3 point something over 4, so like 0.76-ish. Okay? So whatever the decimals are for them. Now the application of these is kind of fun. Where's all my glasses and contacts, kids? Okay? See, your eyeball, or the lens in front of it, is an abnormal shape. That's why things at a certain distance get fuzzy. If you've ever looked through a manual focus camera, if you've ever looked through binoculars, a telescope, anything like that, you have to change the focus on it a little bit. Well, you're changing the focus by cranking that wheel by manually moving the distance between a lens and another lens apart to change the focal point. Well, what I'm doing is changing the eccentricity of the ellipse that would be made with that, effectively your eyeball. If your eyeball is, if your vision is nearsighted, that means that the focal point is too close. That means the eccentricity is too small. That means your eyeball is too close to a circle. If you are far-sighted, that means your eyeball is a little more lozenge-shaped. Now, we're talking by like 1/10 of a millimeter here. It really is that tiny of a difference. Or the lens in front of the eyeball, right? So we got big old eyeball. Oh, by the way, if you have a 3-dimensional ellipse, it's called a prolate. Okay, sometimes called obloid. A prolate, or 3-dimensional ellipse, is that your normal eyeball, normal eccentricity is 0.28. Normal human eyeball. Normal human eyeball is 25 millimeters deep. What are they giving us?
The horizontal, the minor axis.
That is going to be A. It's always longer than it is tall. Okay? Suppose they don't explicitly tell us that. Your eyeball will be longer than it is tall. So I know that this is going to be C over A. I know that that 0.28 is going to be A squared minus B squared over A. So I know that 0.28 is going to be the square root of, if I know that it's 25 millimeters long, what's A? 12.5. Think you can solve and find out how tall that eyeball is? Multiply, square, subtract, divide by negative, square root. Go find B. Remember that B is only half of the distance. How tall be the eyeball? Oh, I got my nearsighted and farsighted, but I always get those backwards. Because nearsighted is the thing that you can't see. I can't see the things close, right? Like it's backwards. And farsighted is I can't see the far stuff, which is completely counterintuitive. It's like the I, E, and C rule all over again. Having flashbacks to third grade. I before E except after C. And then they also list 12 more exceptions.
So like if you spell peace, it's not
Wait, what's this?
I before E except so when you have a C, it's
Yeah.
A before I, but then
My ability to spell flatlined in fourth grade. Because I remember the I, E, and C rule wrong. So I intentionally do it wrong, thinking that I'm going to do it right. But because I remembered that I remember it wrong, I actually did it right in my head and then made it wrong. You should have gotten it was 24 tall. B was 12. Okay. I got some thinking to do because I think we're going to be about a day behind on our chapter 7 stuff. I got thinking to do.